In this video, we'll be learning about X-ray tube, its structure, function, and principle governing the function of X-ray tube, along with types of X-ray tube. I have divided into two parts. This is the part 1 of the video. Coming to overview of structure of X-ray tube, it contains external structure and its internal components or the functioning components. External structure has a supporting structure, the protective housing, and glass or metal envelope which envelopes the internal contents. Internal structure has the cathode and anode. Now we learn about external structure. This is a label diagram of structure of X-ray tube where the protective housing and glass envelope form the external structures, cathode and anode form the internal functioning units, and then there is tube window from which X-ray exits out. Coming to the support structure of X-ray tube, it is the mechanism which fixes the X-ray tube to either the ceiling or to the floor. Sometimes it can be fixed both to the ceiling and the floor, and it can be moved up and down. The fluoroscopy X-ray tubes are usually fixed in the table, that is table mounted, and CR and portable scans have mounted in their units. Coming to protective housing of X-ray tube, it's made of lead because lead gives structural stability and also acts as an electrical insulator. A window or exit port is left in the protective housing for primary X-ray beam to pass through it, and filters of various metals can be added in order to remove low energy photon to reduce patient dose. And if X-ray passes through any other port other than tube window, it's called leakage radiation, and there is always a permissible limit for the leakage radiation in each unit. So protective housing internally contains oil bath which surrounds the glass envelope. This is to remove the heat produced due to X-ray production. Coming to glass envelope, it internally envelopes cathode and anode and contains vacuum as a medium. Vacuum because it controls the number and speed of X-rays moving from cathode to anode. The tungsten in cathode filament and anode can sometimes, because of heat, vaporize and coat the glass or metal envelope. So that condition is called tube aging. It has to be looked at periodically. It can deflect electron beam and it can sometimes filter the X-ray beam. So nowadays metal envelope is used, which is better, having a longer shelf life than glass envelopes. So the glass is nothing but Pyrex. After knowing the external structure, we'll move on to the more important internal structure of the X-ray tube. First, looking at the cathode assembly, it has filaments, focusing cup and connecting wires. Let's first take a look at filaments. The cathode filament is made of tungsten. Tungsten is used because it has a high melting point. It can be drawn into strong and thin wires, and it has a less vaporization potential. Electricity is passed through the tungsten filament, after which electrons are emitted from the tungsten, which is called as thermionic emission. Thermionic because electrons are emitted after the filament heats up. Now these electrons are surrounding the filament, and there's a formation of electron cloud which is called as space charge. These electrons are negatively charged and further prevent electron emission by repelling the further emission of electrons. It's called a space charge effect. These electrons from the cathode which are emitted will move towards the anode after application of a potential difference, that is positive and negative charge, and that current of movement of electrons is called tube current. Coming to the focusing cup, this is a structure which holds the tungsten filament within. It's a cup-like structure which is commonly made out of nickel and kept at negative potential or negatively charged. Normally the electrons move in different directions, but since the focusing cup has negative potential, it is able to focus all the electrons to a point called focal spot on the anode. This focal spot is dependent on the shape and the charge given to the focusing cup. So the newer tubes have two filaments with two focusing cups, and the larger filament is used for short and high intensity exposures, and the smaller filament is used when longer exposures are required with higher resolution. Focusing cup and filaments are kept in high negative voltage and anode is kept in high positive potential. This helps electron to move from cathode to anode, which is called tube current. Coming to the last part, that is connecting wires and cathode assembly. They are the ones which are insulated and provide high negative potential for the filament. We're done with cathode and now moving on to anode assembly. Anode is made of tungsten because of its high atomic number, a high melting point, and a low vapor potential of the metal. This can be combined with 10% rhenium, which improves its resistance to thermal damage. Okay, and there are types of anodes. Stationary anode, which was used in old tubes, not used now. Nowadays rotating anode is used. We'll see them in detail. Coming to stationary anode. Stationary anode looks something like this, where a tungsten plate or a tungsten target is fixed over a copper anode block. Copper is a good conductor of heat. It dissipates the heat to the oil bath. Nowadays stationary anode is used in dental X-ray and portable X-rays because rotating anode is a complicated mechanism to use in such machines. Coming to rotating anode, it's a disc of anode plated with tungsten, looks something like this, which has a tungsten target. Since it rotates, it provides more effective surface area of the target. Rotates at around 3000 rotations per minute or RPM. It increases heat resistance or the heat tolerance capacity. This disc is planted over a molybdenum stem. Molybdenum prevents thermal damage. The mechanism for rotation, the rotor and the stator with all its bearings are placed outside the glass envelope or outside the tube, again to prevent thermal damage. All these are lubricated with liquid metal. Usually silver is used, again to prevent heat damage. Let's cut the rotating anode disc in cross section and see the structure in detail. Over the surface we have tungsten target, which also shows that beveled edges. Inner to it we have the molybdenum, which makes anode lighter, also plated on a molybdenum stem. Next, the third layer, we have a graphite block which removes heat. We have seen X-ray tube structure in detail, and in part 2 of the video we'll see the principles which govern the X-ray tube, factors governing the tube life, types of X-ray tube, and more importantly, among the types we'll see the mammography X-ray tube, which is an MD exam question. For more such videos, please follow us on YouTube and Instagram at Radiology Doodles.